In the previous videos, we learned about Python variables, which serve as containers for data values. However, what we didn't cover was that not all containers in Python are alike. In fact, we handle data using a combination of data types and data structures. Data types can be viewed as the basic units or building blocks of data. These units can then be organized and managed using data structures, which allow us to handle these units in a more intricate and effective manner. For example, in our Python kitchen, data types are the basic ingredients we use. Each ingredient, like flour or sugar, is stored in its own individual container, like a bag or a jar. However, these containers can be very different. Some are small, some are large, some are easy to pour from, and others might be airtight. In Python, even a simple ingredient like a number or a piece of text is stored in its own specific kind of container. On the other hand, data structures in Python are like the larger storage units or cooking tools we use in a kitchen. These could be the cupboards where we store multiple bags of ingredients, the mixing bowls where we combine ingredients, or the oven where we bake a mix of ingredients together. Just as these storage units or tools help us to organize, combine, and cook our ingredients in more complex ways, Python's data structures help us manage and manipulate our data types to create more complex and meaningful data arrangements. Let's now take a look at the data types to better understand this. As previously mentioned, data types are like individual units of data. The basic data types are as follows: integers, floating point numbers, Booleans, strings, and none type. Let's take a look at each of these in more detail in order to better understand the differences, as each data type is designed to handle a specific kind of data. An integer, or int, is like a counter that keeps track of a certain number of items. For example, we would use integers to count the number of apples in a basket. Integers are represented by whole numbers, which are numbers that are not fractions or ones with decimals. A floating point number, or float, is a kind of numerical value that represents real numbers, including fractions and numbers with decimal points. It can be used to represent measurements that require decimal precision, like the weight of an apple at 0.23 kilograms, or the amount of sugar needed in a recipe, such as 1.5 cups. A Boolean, or bool, can be compared to a light switch that can be either on or off, represented in Python as true or false. It could be used to signify whether an apple is ripe, true, or not ripe, false. A string, or str, serves as a label that holds text information. It's like a name tag on a lunchbox that says sandwich, or a label on a jar that says orange marmalade. Strings can hold any sequence of characters, including letters, numbers, spaces, and punctuation. This is the data type that we previously used in our variables tutorial. None, or none type, in Python is like an empty container. It symbolizes the absence of a value or the fact that nothing is there. For example, if you have a basket designated for apples but there are no apples in it at the moment, the basket's state could be represented as none. Each of these data types is designed to accommodate a specific kind of information. Python, being a dynamically typed language, can automatically identify the data type based on the value you assign to a variable. This means you don't need to explicitly declare the type of data a variable will hold. However, while Python handles the initial assignment of data types dynamically, it does not automatically convert between different data types in all situations. Therefore, being aware of the kind of data each type can handle is essential. This knowledge helps avoid errors and ensures that the data is handled efficiently and as expected in your program. Let's take a more detailed look at the Python code for each of these data types in our Python kitchen. Imagine you're preparing to make several apple dishes. Each dish requires a certain number of apples, and you need to keep track of this. You also want to maintain a catalog of apple varieties along with their descriptions and a shopping list for other ingredients. Let's take a look at how we can make use of these data types and structures in this situation. Integers in Python are values assigned to a variable that only contains a numerical whole number, which are numbers without a decimal point. We could, for example, use integers to count the number of apple varieties in a basket, as this represents whole numbers without decimals. Let's say we have three types of apples, or variables, in our basket, being Granny Smith, Golden Delicious, and Pink Lady. We can then assign and store integer values to these variables in order to keep count of how many of each type we have. When we do, our code will look like this. Granny _ Smith _ apples equals 5. Golden _ delicious _ apples equals 3. Pink _ lady _ apples equals 2. In this code, Granny _ Smith _ apples, Golden _ delicious _ apples, and Pink _ lady _ apples are variables that store the number of apples of that variety, represented as an integer value. When we print these three variables, we get their respective whole number values in the output as 5, 3, and 2. When you're learning to code, it's important to know what type of data you're dealing with at any given time. That's where the type function comes in. By using type, opening parenthesis, closing parenthesis, you can confirm the data type of any object in Python when the data type isn't immediately obvious from context. For example, we can use the type function to show us what data type the variable granny_smith_apples is assigned to by typing print opening parenthesis, type, another opening parenthesis, granny_smith_apples, followed by 2 closing parentheses. When we run this code, Python outputs the data type of the value within the granny_smith_apples variable, which in this case is the number 5, which is an int or integer. Int, in this case, is also known as the keyword for integers in Python. Therefore, by using the type function, we have confirmed that an integer is assigned to the granny_smith_apples variable. Great. Now let's look at some arithmetic operations we can do with these integers. Python provides several basic arithmetic operations that allow you to perform mathematical calculations on numbers. You can use them to add, subtract, multiply, and divide numbers. Let's take a look at some examples of how we can use these operations in Python with integers. We can use the addition operator if we want to know the total number of apples in the basket. This operator helps us to add up the numbers in Python, and it's symbolized by the plus character. In our case, we have 3 different types of apples: Granny Smith, Golden Delicious, and Pink Lady. Each type is represented by a variable holding the respective count of that apple variety. By using the addition operator, we can sum up these variables in order to get the total number of apples in our basket without having to enter the integer values directly, as they are already stored in the variable containers. To do this, we also need to create a new variable and name it total_apples, then add the other 3 apple variables within it. When we print total_apples, we see that Python successfully calculates the total number of apples in the basket by adding the counts of each type of apple variable. The result stored in the new total_apples variable is then 10, indicating that there are 10 apples in the basket in total. In the same way that we use the addition operator, we can use the subtraction operator if we want to know the difference in the number of apples between 2 varieties in the basket. This operator helps us to subtract one number from another in Python, and it's symbolized by the minus character. By using the subtraction operator, we can subtract the count of one apple variety from another without having to enter the integer values directly, as they are already stored in the variable containers. To do this, we create a new variable and name it more_apples. We then subtract the Pink Lady from the Granny Smith variable within it. When we print more_apples, Python successfully calculates the difference between the number of Granny Smith and Pink Lady apples in the basket by subtracting the count of Pink Lady from Granny Smith. The result stored in the new more_apples variable is then 3, indicating that there are 3 more Granny Smith apples than Pink Ladies in the basket. We can use the multiplication operator if we want to calculate the total cost of a certain type of apple in the basket. This operator helps us to multiply numbers in Python, and it's symbolized by the star character. Let's say each Granny Smith apple costs $2. This cost is a raw integer value that we're providing directly in our calculation and not assigning to a variable, although we could do that too, but I won't for this example purpose. To calculate the total cost of Granny Smith apples, we multiply the count of Granny Smith apples by the cost per apple, a raw integer value that we're providing directly. Here's how we do this. In this code, we're creating a new variable called total_cost and assigning it the result of the multiplication of the variable granny_smith_apples by 2. When we print total_cost, Python calculates the total cost of Granny Smith apples by multiplying the count of apples stored in the variable by the cost per apple, a raw integer value. The result is stored in the total_cost variable, which is 10 in this case, indicating that buying 5 Granny Smith apples will cost $10. This is an excellent example of how Python allows us to combine integers assigned to variables with raw integer values to perform calculations and solve real-world problems. We can use the division operator if we want to calculate the average number of apples per variety in the basket. This operator helps us to divide one number by another in Python, and it's symbolized by the slash character. Using the same 3 apple variables and integers assigned to them, we first need to find the total number of apples by adding them together and assigning the total to a new variable called total_apples. This is the same step that we previously did in the addition operator section, where we saw that this value is 10. Next, we want to find out the average number of apples per variety. To do this, we create a new variable called average_apples and assign it the result of the division of total_apples, being 10, which is divided by 3. 3 being the number of apple varieties being Granny Smith, Golden Delicious, and Pink Lady. When we print average_apples, Python calculates the average number of apples per variety by dividing the total count of apples by the number of varieties. The result is stored in the average_apples variable, which is approximately 3.33 in this case. This indicates that on average, we have about 3.33 apples of each variety in the basket. Notice that the result of the division operation is not a whole number or integer, but instead a decimal value. This is known as a floating point number, and we are going to look at this data type next. As a side piece of information, Python automatically converts the result to a float when the result is not a whole number. This is an example of Python's dynamic typing feature, which automatically determines the data type based on the context. We can confirm this using the type function. When printing average_apples in combination with the type function, we can see that the resulting output of 3.33 is indeed a float. Floating point numbers in Python are like a precise kitchen scale that measures weights with decimal accuracy. For instance, you can use a float to represent the weight of an apple or the amount of sugar needed in a recipe as follows. Apple_weight_kg equals 0.23. Sugar_cups equals 1.5. In this code, apple_weight_kg and sugar_cups are variables that represent the weight of an apple and the amount of sugar needed in a recipe, respectively. When you print their types, it outputs class float, indicating that these variables are floats and that the keyword for floating point numbers is float. As with integers, we can also do arithmetic equations using floating point values. Let's start by assigning weight values to each of our 3 apples in kilograms. Granny_Smith_weight equals 0.2. Golden_Delicious_weight equals 0.25. Pink_Lady_weight equals 0.22. In this code, we're assigning the weight of each type of apple to a variable. The weights are in kilograms and are represented as floating point numbers or decimals. Now let's again use the addition operator to calculate the total weight of all 3 apples by assigning them to a new variable called total_weight. Here is how the code for that will look. Total_weight equals Granny_Smith_weight plus Golden_Delicious_weight plus Pink_Lady_weight. Once again, when printing the new total_weight variable, we're adding the weights of the 3 types of apples to find the total weight, but this time the result is a decimal value or floating point value of 0.67. If a floating point value is used in Python with an operator, the output result will always be a floating point value as well. In other words, even if the result is a round number such as 1, the output will be 1.0. Now let's use the subtraction operator to calculate how much heavier a Golden Delicious apple is compared to a Granny Smith apple. To do this, we will again create a new variable called weight_difference and assign the equation to it. When printing the weight_difference variable, we see that it outputs 0.0499 recurring. You might find this odd, as when using a standard calculator, you would know that the weight of the Golden Delicious apple of 0.25 minus the 0.2 weight of the Granny Smith should equal 0.05 and not 0.0499. The reason for this is how binary code works in computers, and therefore it's not the fault of Python. Binary is an advanced topic, so I am not going to explain this here. I just wanted to mention it in case you were confused or wondering why this was happening. We can, however, solve this in Python by using the round function. To do this, all we need to do is encapsulate the assign Golden_Delicious_weight minus Granny_Smith_weight inside the round function's parentheses. When printing this again, the result is an output value of 0, which is also not correct. To fix this, all we need to do is put a comma and a 2 after the Granny_Smith_weight variable. This tells Python that we want to round the floating point to 2 decimal values, resulting in a new floating point value of 0.05. Next, let's use the multiplication operator to calculate the total weight if we buy 5 Granny Smith apples. To do this, we will create a new variable called total_weight_Granny_Smith. Then we need to assign the Granny_Smith_weight variable to it, as well as multiply it by 5 using the star character. When printing this out, we can see that Python outputs a floating point value of 1.0 and not a rounded integer value of 1, as I mentioned earlier. While this result is perfectly correct, we can again use the round function here if we only want to have a whole number of 1 as the output. To do this, we will again encapsulate the assigned granny underscore Smith underscore weight times 5 inside the round function's parentheses. As we don't want any decimal values, we will leave it as is. When we now print this out, we will get a rounded value of 1 without the .0 decimal value. However, one very important thing to note here is that it is no longer a floating point value, but instead has changed to an integer. We can confirm this using the type function again, which shows that it is indeed an int and no longer a float. Lastly, let's use the division operator to calculate how many Granny Smith apples make up 1 kilogram. To do this, we will first create another new variable called apples underscore per underscore kg. We will then assign the value of 1 kilogram to it and divide this number by the Granny underscore Smith underscore weight variable, which in this case represents a value of 0.2 kilograms. When we then print this number, we get an output value of 5.0. Here again, the same rules apply with the round function if you want to use it to round to an integer of 5 instead of the floating point value of 5.0. There are many reasons as to why you would want to do this in Python. Here are some real-world reasons as to why you want or need to convert a 0 float to an integer. Memory usage. While the difference is very small and usually not a concern, an integer does use slightly less memory than a float in Python. If you're dealing with a very large amount of numbers, converting them to integers could potentially save memory and increase performance of your code. Indexing lists or arrays. In Python, when you're indexing lists or arrays, the indices must be integers. If you've done a calculation that results in a float like 5.0, you'll need to convert that to an integer before you can use it as an index. We will learn about lists next in the Python data structures section. Compatibility with certain functions. Some Python functions or libraries may require integers as inputs. For instance, the range function in Python requires integer inputs. So if you have a float like 5.0 and you want to use it with range, you'll need to convert it to an integer first. Visual presentation. When printing numbers or presenting data to users, it might be more visually appealing or simpler to understand if numbers are presented as integers rather than floats. For example, saying 5 apples instead of 5.0 apples looks much better on a chart or table. Database operations. When dealing with certain databases, you might need to store data as integers instead of floats. If the database field is defined to hold integer values, we'll need to convert your floats to integers, even if the float is a whole number like 5.0. Remember, the decision to convert a .0 float isn't always necessary, but is instead largely dependent on the specific requirements of your Python code or project. Strings are an ordered sequence of characters. They can contain words, numbers, and foreign characters. Strings are denoted by either double quotes or single quotes. In the previous variable tutorials, we were using strings to create our values. Remember that strings are a data type, which means that they only refer to the value assigned to the variable, not the label of the variable itself. While technically the variables are also created using what seems to be a string, they are not. Only the value can be a string. An easy way to remember the difference is that the value string will also require either double quotes or single quotes, while a variable does not. Strings can also use spaces and other foreign characters, which variables cannot. While we have covered strings thoroughly in the variables tutorials, let's again look at an example for clarity's sake. We will begin by creating 3 variables, calling them Apple1, Apple2, and Apple3. We then assign each of these variables the string values of our 3 apples, being the Granny Smith, Golden Delicious, and Pink Lady. Note that the variables don't have quotation marks, but the assigned variable strings do. When we print the type of Apple1, it outputs class str, indicating that the variable is a string data type. In other words, the keyword for strings in Python is str. Strings in Python can also be combined using the addition operator. This is known as string concatenation. To do this, we first create a new variable called apple_basket. We then assign our 3 apple variables to it as apple_basket equals apple1 plus apple2 plus apple3. In this code, we combine the string variables apple1, apple2, and apple3 into a single variable named apple_basket, which represents the contents of our apple basket. When printing out the apple_basket variable, the code will execute successfully, but you will notice that there are no spaces between the apple name values. To fix this, we need to manually add spaces in the print statement by using more addition operators, together with double quotation marks. Now the apple_basket variable assignment will be as follows. Apple_basket equals apple1 plus double quotation marks, comma, space, double quotation marks, plus apple2 plus, double quotation, comma, space, double quotation, plus, apple 3. This time the output not only created a space between the variable values, but also a comma, as we typed comma space between the quotation marks in the print statement. In other words, we can actually type whatever we want in between the double quotation marks, and it will be concatenated within the print statement. For example, we can add more strings to create a sentence based on each apple's taste. Let's add the sentences. Is green and tart, is crisp and sweet, and is sweet and juicy after each of the apple variables to describe them, instead of just the comma space that we currently have to separate their names. To do this, our line of code will now look like this. Apple underscore basket equals apple 1 plus double quotation marks, space, is green and tart, comma, space, double quotation marks, plus apple 2 plus double quotation, space, is crisp and sweet, comma, space, double quotation, plus, apple 3, plus, double quotation, space, is sweet and juicy, period, double quotation. When we run this code, Python now outputs a full concatenated sentence that describes the 3 apple varieties together with a description of each one's taste and appearance. This illustrates the power of combining strings and variables together with custom strings, allowing you to create any sentence or paragraph that you like in Python. In Python, strings are ordered sequences of characters. This means that each character in a string has a specific position or index, starting from 0. The index refers to the location of an element in the string. Let's take the string apple as an example. In Python, this string is indexed as follows. A for apple is at index 0, followed by the first P at index 1. The second P is at index 2, followed by L at index 3, and lastly, E is at index 4. This zero-based indexing system is common in many programming languages. It's important to remember that the first element is at index 0, not 1. We can access individual characters in a string by their index in a couple of ways. The most straightforward way is by placing the index in square brackets after the string or the variable containing the string. For example, we have a string variable called fruit with an assigned string of apple. To get the first character at index 0, we can use indexing by typing fruit opening square bracket 0, closing square bracket inside the parentheses of our print statement. When we run this code, we can see that Python will return capital A, which is the first character of the value apple at index 0. Just remember that string indexes must be integers. If you try to use a non-integer such as a float or a string as an index, Python will give you an error. For example, let's try to use a float value of 0.4 as an index. When trying to print this, Python outputs a type error stating string indices must be integers. We will also get an error if you try to access an index that does not exist in the string. For example, let's try to access fruit 5 in our apple string. Here again, we get an index error that states string index out of range. This confirms to us that the index value of 5 does not exist in the string of apple. We could also use indexing to access a range of characters within a string. For example, in the variable apple underscore basket, we have our concatenated string, Granny Smith, Golden Delicious, Pink Lady from earlier. But what if we want to slice and extract only a section of this string? Well, we can easily do that using indexing and specifying the range of characters that we want. Say, for instance, that we wanted to slice out the characters Granny Smith from the apple underscore basket variable. Let's take a look at how many characters that is and which indexes they fall under. Starting from index 0 is the capital G of Granny Smith. Following this are the characters R, A, N, and Y, which occupy index values 1 to 5. At index value 6 is the space between Granny and Smith. While this is only an empty space, it too is assigned an index value, which in this case is 6. From here is the capital S of Smith at index 7, followed by M, I, T, and H at indexes 8 to 11. Let's now take this index range and use it to slice index values 0 to 11 from the apple underscore basket variable's assigned string. To do this, we first need to create another variable called first underscore apple and then assign apple underscore basket to it. With that done, we now need to apply an index range of characters 0 to 12 to it, using a colon in between 0 and 12. When printing out the variable first underscore apple, we get the result of this range or slice of Granny Smith, as these are the first 12 characters of the string. You might notice that the last character is actually 11 and not 12. This is because of the 0. So effectively, what we are telling Python is that we want the first 12 characters as a substring, including the 0, meaning that 11 will be the last character that it outputs. A less complex way to remember this is to simply always set the end range one character more than the last character that you want to slice. In other words, as we want it up to character 11, we set one more than this, which is 12, resulting in Python outputting up to the 11th character. The len or length function can be used to find the length of a string, which is the number of characters, including spaces and punctuation, that it contains. To find the length of our string, we need to first create a new variable called basket_length. To it, we will assign the length function and pass the apple_basket variable as an argument. This is a fancy coder's way of saying that we place the apple_basket within the length function's parentheses. When this occurs, it is referred to as the argument of the function. We did the same thing when we used both the type and round functions. We passed arguments into these functions as well. I simply did not refer to them as arguments at the time in order to keep things more simple and easy to understand. However, as you are now progressing well and learning more about Python, I thought I would teach you the correct terminology. Anyway, let's continue with our code, which will look like this. Basket_length equals len, opening parenthesis, apple_basket, closing parenthesis. When printing out the basket_length variable, we calculate the length of the apple_basket string using the length function. The result stored in basket_length is 41, indicating that the string apple_basket contains 41 characters. Here's how Python counts these characters. Granny Smith is 12 characters long, made up of 11 letters and 1 space. Golden Delicious is 16 characters long, made up of 15 letters and 1 space. Pink Lady is 9 characters long, made up of 8 letters and 1 space. We also have 2 instances of a comma, followed by a space between the apple names, each of which is 2 characters long. So the total length is therefore 12 from Granny Smith, plus 16 from Golden Delicious, plus 9 from Pink Lady, plus 4 for the 2 comma space separators, which equals to 41 characters. We can confirm these numbers by also printing out the individual apple variables. Here we can see the same results as 12, 16, and 9. Booleans in Python are like simple yes and no indicators. A Boolean can be compared to a light switch which only has 2 states, being on or off. For instance, we can use a Boolean to signify whether an apple is ripe, using the following code. Apple _is_ ripe equals true. In this code, the variable apple is ripe is assigned a Boolean to represent whether an apple is ripe or not. When we print its type, it outputs class bool, indicating that the variable is a Boolean and that the keyword for Boolean is bool. Now let's move from the arithmetic operators that we learned about in integers and floats to another operator family called logical operators. Logical operators allow us to connect Boolean values and expressions, creating more complex conditions and logic in our code. There are 3 main logical operators in Python: and, or, and not. The AND operator returns true if both the operands, values on the left and right, are true. The OR operator returns true if either of the operands is true. The NOT operator returns the inverse of the operand. If the operand is true, it returns false, and vice versa. All right, I understand that this is most likely very confusing at this point. So let's write some code to see these operators in action, and thereby get a better understanding of how they work. Before looking at each of these 3 logical operators in more detail, let's first clarify the difference between an operator and an operand, as this is vital to understanding them. An operator is a symbol that performs a specific operation on one or more operands. For example, in Python, the arithmetic operators plus, minus, multiply, and divide, together with the logical operators and, or, as well as not, are all operators. An operand is a raw value or a variable that holds a value on which the operator performs the operation. For example, in the expression 3 plus 4, the values 3 and 4 are operands, while the plus is the operator. In other words, 3 and 4 are the operands or values being operated on by the operator. If we look at our string concatenation from earlier as an example, The apple one, double quotation marks, comma, space, double quotation marks, apple 2, double quotation, comma, space, double quotation, and apple 3 are the values being operated on by the plus operator. So as you can see, it's not actually as complex as it may sound, so hopefully this clears things up. With that in mind, let's now look at each of the three logical operators. The AND operator in Python checks if both the operands, values on the left and right, are true. If both operands are true, it returns true. However, if one or both of the operands are false, it returns false. All right, that's enough theory. Let's put this into practice to see how it works. Let's use Booleans and the AND operator to tell us if the apple is ripe and ready to eat, or sour and not ready to eat. For example, we already have the variable called apple underscore is underscore ripe and have assigned a Boolean value of true to it. Now let's create another variable called apple underscore is underscore sour and assign a Boolean value of false to it. Lastly, let's create one more variable called ripe underscore and underscore sour. Then we assign the first variable to it, followed by the AND operator, followed by the second variable. In this code, we use an operator to check if both apple is ripe and apple is sour are true. The result is stored in the ripe and sour variable, which when printing it out states false, because while the first variable is true, the second one is false. In other words, as the AND operator requires both operands to be true in order for it to output true, it instead outputs false as this requirement was not met. This is what the AND operator does. It checks if both operands are true. With that said, the question remains, can we eat the apple? Well, the current code actually won't help us determine that because we are asking if the apple is both ripe and sour, which technically cannot exist at the same time. It has to be either one or the other. Thus the print result of false. So while the code is providing us with the correct answer, it isn't the answer we are looking for. In order to fix this, we need to adjust the code slightly by changing the conditions in such a way that a true value represents the desired state. First, we need to change the second variable from apple is sour to apple is not sour, and then assign it a Boolean value of true instead of false. Next, we can change ripe and sour to ready to eat, as this makes more sense. As we change the variable name of apple is sour to apple is not sour, we need to make sure to make the same change in the assignment value of ready to eat as well. Otherwise, the code will give an error. If we now print the ready to eat variable, we get an output result of true. This tells us that both the operands apple is ripe and apple is not sour are true. Thus, the AND operator's requirements have been met. As both are true, the resulting output is also true, thereby telling us that our apple is in fact ripe and ready to eat. As you can see, the naming and structure of your variables and values is very important in order for it to not only make sense, but also to output the required results. The OR operator in Python checks if either of the operands, values on the left and right, is true. If either operand is true, it returns true. However, if neither of the operands are true, it returns false. Let's again check if we can eat the apple, at this time using the OR operator. Using the same code, let's make a few small adjustments. First, let's change the second variable from apple is not sour to apple is sweet. While this technically says the same thing, apple is sweet, is easier to read and understand. Next, let's change its value from true to false. Lastly, we must change the AND operator to an OR operator. When we print this code, we use the OR operator to check if either the values within the variables, apple is ripe or apple is sweet, is true. The result stored in the ready-to-eat variable is true. This is because at least one of the operands is true, which in this case is the apple is ripe value. This tells us that even though the apple isn't sweet and might not taste great, it is however ripe and therefore edible. Now, what will happen if we reverse the Boolean values by changing apple is ripe to false and apple is sweet to true? When printing this, we can see that we again get an output of true. This tells us that if the apple is sweet, it is also ready to eat, as that indirectly makes it ripe. This is what the OR operator does. It checks if at least one of the operands is true. The NOT operator in Python returns the inverse of the operand. If the operand is true, it returns false and vice versa. For example, let's say that we want to only eat the apple if it's ripe and not sour. To do this, we first need to change apple is sweet to apple is sour. Then we need to change its assigned value from true to false. Now, instead of comparing the two operands as we have been doing thus far, we will simply use the not operator to invert the Boolean value of the apple is sour variable. This changes it from its initial assigned value of false to true. When printing the ready-to-eat variable, we can see that it outputs a value of true, telling us that the apple is not sour and therefore ready to eat. This is what the not operator does. It inverts the Boolean value of the operand. And that brings us to the end of this video. If you've made it this far, I sincerely hope that you enjoyed the content and have learned something new. If so, please leave a like and subscribe if you have, as well as to get notified of any future videos. Oh, and make sure to check out this video as well. You can also subscribe over here. And this one is pretty cool too.